Okay, let's complete the rest of the test. Question 11 talk about figure 2.1 shows up a motorcyclist accelerating along a straight horizontal section of track. The motorcyclist and the motorcycle have a combined mass. So if you want to find the given, to make it clear for you, mass equal 240 kilograms, so you don't need to convert. On the straight horizontal section of the track, the motorcyclist accelerate from rest, which means u equals 0, at 7.2 meter per second squared. So if you see meter per second squared, it should be acceleration, because the unit of acceleration is meter per second squared. So it is 7.2 meter per second squared. And he said what? The time the motorcyclist reached the end of the straight section of the track in time equal 5.3 seconds. Calculate the speed. He asked to find the final speed. As you know, acceleration equal v minus u over time. So acceleration is 7.2 v minus 0 over time, which is 5.3. Now you can make a cross multiplication, so it will be v minus 0, which is v equal 7.2 multiply 5.3. Okay, this will be the answer. The answer will be 7.2 multiply 5.3 equal 38.16 meter per second. Calculate the resultant force. He asked to find resultant force, which is F net equal mass multiply acceleration. We have mass here is 240 multiply acceleration is 7.2. So the answer will 7.2 multiply 240 equal 1728 Newton. At the end of the straight section, the track remains horizontal but bends to the right, as shown in the figure 2.1. When the motorcyclist reaches the bend, she travels around the bend in a circular path at the constant speed. Velocity is a vector quantity. State how a vector quantity differ from scalar. All of you know that vector has magnitude and direction, but scalar has only magnitude. Describe what happened to the velocity of the motorcycles as travel around the bend at a constant speed. It means velocity change in direction, because moving in a circle will change the direction in each position. For example, for this part, will be the velocity in this position, this will be the velocity, and so on if the object move in this direction. So as you see, velocity is changing in direction in the circular motion. Battery provides energy to an electric car. The electric car has acceleration. He gave me acceleration equal 2.9 meter per second squared. When it moves from rest means u equals 0. The combined mass of the car and the driver is combined mass equal 1600 kilogram. Calculate the time taken. He asked to find time. If the final speed is 28 meters per second, so first you can use acceleration equal v minus u over time. We have acceleration, which is 2.9 equal v 28 minus 0 over time. You can use cross multiplication. So t equal 28 over 2.9. And the answer will be 28 divided by 2.9 equal 9.65. So it can be rounded to 9.7 second. Calculate the force required to produce this acceleration. F net equal mass multiply acceleration. Mass is given 1600 multiply acceleration, which is 2.9. So the force will be 1600 multiply 2.9. So it will be 4640 Newton. Calculate the kinetic energy of the car when its speed is 28. Kinetic energy, half multiply mass multiply speed squared. So it will be half multiply 1600 multiply speed is 28 squared. Don't forget squared, okay? So 28 squared multiply 1600 multiply half equal 627 200 joule. The unit of energy is joule. Now let's move to the next. He asked to find, label a point on the graph where the acceleration is 0. Acceleration is 0 when the speed time graph, the line is horizontal. So this is 1, acceleration 0. Also this is 1, acceleration 0. Negative, and negative it means deceleration, so it will be 2. You can write on the line 2, deceleration, negative acceleration. Decreasing acceleration, which will be 3, this part, because gradient decrease, okay? A force is a vector. State two features of vector quantity. Vector has magnitude and direction, okay? State the names of two other quantities that are vectors. Yes, we have, for example, velocity and acceleration. Also, you can use you can use momentum, but you can't mention to force because force is given in the question, okay? Now let's move to the next. He asked in this question to determine the initial length LO of the spring. As you know, this is the initial length because this is weight with length. So the length of a spring start from LO. This is LO. How you can read it? Okay, no problem. You can subtract this value, two successive value, 0.2 minus 0 over number of squares, which is 10. So each small square equals 0.02. Now you can count 0, 0.02, 0.04, 0.06, 0.08, 0.1, 0.12. So LO equal 0.12, 0.12, 0.12. Okay. Now state what's meant by limit of proportionality. This is the limit of proportionality is the point beyond it the extension is directly proportional with force. Okay, you can also use the limit of is the point beyond it the graph force extension graph will be linear. Also you can use there is a proportional between extension and force. Okay, what is the weight at limit of proportionality? So you can go and use your ruler and try to reach to the end of the straight line. As you see, this point is the end of the straight line. So now you can make a line to know what is this point at weight. Okay, read it, because this is 2 divided by 10, so each quarter or each square equal 0.2. So now we have, this is 10, 10.2, 0.4, 0.6, 0.8, so it can be 10.8 or 11. Both are accepted, so you can write 10.8. And what is the unit? Newton. Determine the spring constant. Spring constant K equal force over extension. So what is the force? You can use any force from anywhere divided by the extension, and pay attention how you can find the extension. For example, I will use 8. So I will go to the line and find what is the length at this weight. It will be 0.4, 42, 44, 46. It's 0.46. So now we have LO and L. To find extension, you have to subtract L minus LO first. So you can write the equation like this: force over L minus LO, because extension is length minus stretched length minus unstretched length. Force is 8 minus 0, which is gradient. L is 0.46, 0.46 minus 0.12, so it will equal 0.46 minus 0.12 equal 8 over 0.34 equal 23. So K equal 23.5, and the unit is Newton per meter. Because, but you have to be sure the unit of length is meter. Okay, because sometimes he gives you in millimeter, so you have to change the unit to Newton millimeter. Okay, now let's move to question 14. What is the given in this question? He gave only mass, a rock climber of total mass 62 kilogram, holds herself in horizontal equilibrium against a vertical cleft. She pulls on a rope that is fixed at the top of the cleft and presses her feet against the cleft. Okay, show her position. Okay, this figure show her position. Calculate the weight, the total weight. So as you know, weight equal mass multiply gravitational field strength. Mass is 62 multiply gravitational field strength is 9.8 on the Earth's surface. So you have to multiply 62 multiply 9.8 equal 607.6 Newton. State the two conditions needed for equilibrium. For equilibrium, yes, net force equals 0, and also total moment equal what? Equal 0. Okay, the climber's center of mass is 0.9 from the cleft. Yes, this is the distance for the weight, 0.9. Okay, calculate the moment about her feet due to weight. So moment of weight equal force multiply distance. So force equal what? Force, which is the weight, we find it 6.7.6 multiply distance with 0.9. So the answer will be 546.84 Newton meter. Okay.